Hello, everyone. Welcome to MAThurdays. Math's so fun. We do it on Saturdays. So glad you're here today. As we go ahead and get started, you're going to need access to the collaborative slides. Now, since you're in Zoom, I'm assuming you already have access, but I'm going to go ahead and put it down there in the chat box. And on slide 2, I've got some contact information. Feel free to reach out to me. Our math routine for today is visual patterns, and our task is what's next. On slide 3 are some great bookmarks. If you're new, welcome. You might want to bookmark these. I have a bunch of templates that can be used for online or in-person learning with technology. And the second link is where I keep all the other MAThurdays. So we have over 50 here. We do this every Saturday. And there is a routine and a rich task for almost every week. And then join me down on slide 4 or 5 and share with us your successes and celebrations. The easiest way to share is through a text box. But as you can see, this is unstructured on purpose. People add images, emojis, bitmojis, GIFs, and more. So feel free to add there. And tell us about mangoes. On slide 4, someone wrote something in there about it being the king of fruits. Do you eat a lot of mangoes around this time?
Hi, it's nice to be here, Teresa. Yes, we do. It is summer in India, and it's mango time. Yes.
Wonderful. Well, glad that you are here. Awesome. And Lisa, how was the birthday party?
We had a lot of fun. We went to the park, and then afterwards, the next day, my daughter and son-in-law took a 2-night trip, so we got to stay and babysit. Lots of fun.
Oh, lovely. And Lara and Raha, is that both of you there in that picture? And congrats on completing the school year. What are you most looking forward to next year?
Hi, Teresa. Yes, we did it. I don't know how we did it, but we definitely did it. I think I am looking forward to having kids back in the classroom. I'm not a very good virtual slash in-person teacher at the same time. I think I prefer either all virtual or all in person. So I'm just grateful that next year maybe moving forward and it'll be all in person. I miss having kids in person. I think we have a better connection that way.
Yeah, well, congrats, you did it. I know concurrent is incredibly challenging. My kiddos just finished their school year also. They've been virtual all year, but some of their friends were physically in class. So that we experienced that one too. And who's getting out with friends this summer? It is lovely now that we're able to get vaccines and get able to see people again. Who's that? And where are you going? What are you going to be doing?
Hi, Teresa. I'm basically just going to lunch with my friends that I have not seen, some of them in over a year and a half. So it's just been great getting to see some of my old teacher friends that I haven't seen for a long time.
Oh, lovely. Well, welcome everyone. I always like to start off with successes and celebrations, like you saw on slides 4 and 5, as a way of just bringing us together as a community to welcome people who this is our first MAThurdays, and to just connect with people who kind of come regularly and share these connections. And to get to show off some cool things with some other people who really get you in the math world. So as we continue, we're going to do a math routine and a rich task today. Our routine is on slide 7, and there is a link to Fawn's website for visual patterns. Definitely check that out. And this is an established routine that I am going to try to bring into this online setting and model it this way. So for this routine, you're going to need to find your chat box. So sometimes that means minimizing your Zoom or your browser window. Zoom is behind it. You've got a chat box somewhere. Go ahead and find that chat box. And we're going to do a chat waterfall, which means you're going to type in your chat box, but don't hit enter yet. We're all going to hit enter at the exact same time. So we've got a pattern on slide 8, and I'm showing it on Zoom. Oh, no, I'm not. Let me get it on. There we go. I'm showing it on Zoom. We have a pattern on slide 8, and in your chat box, you're going to use words to describe the pattern. It's trickier than we think. Use words to describe it. You're going to put that in the chat box, but don't hit enter yet. We're going to give enough wait time for everybody. So use words to describe the pattern. If you think you've described one pattern, think of another way of describing it. And let's let the waterfall begin. Go ahead and hit enter. We're going to see some responses in the chat. But much like a waterfall, it doesn't all dump out at once and stop. It continues, so feel free to keep putting new ideas each time. And we can take a minute to read through these. And Roanna, I'd love to start with you. Your comment was increases by 12, and I'm going to put that comment here on slide 9, where I'm going to bring up a couple of them. Can you tell us, how do you see this increases by 12?
Hi, Teresa. So I can see that there is two dices that are increasing, and the value of the dice is 6 each. So that's why it is increasing by 12, vertically and horizontally, 6, 6. So that's why 12.
Oh, so let's see if I can bring that on here. We'll take that image again. And the new dice you said are 6 and 6. I love the way that you brought the numbers into this. And am I drawing the arrows at the dice that you said are the new ones?
Yes.
Great. Let's see, there's so many great ideas in here. Julie, you bring up this this idea that growth pattern, each dimension grows by 1 with each additional stage. I'd love to hear more about how you see that, and I'll try and model it as you're chatting.
I was kind of looking at the same thing that you showed with the arrows in the last one, where each time you're seeing the height increase by 1, and then also the length increasing by 1 dice. So the first one, and I called the first one a 3 by 1 because I looked at the orientation of the dots, and since that red dot had them going the same direction as the ones above it, I considered it part of the height.
So when you say 3 by 1, is it like the red and the pink showing a 3 and a 1?
Yes. Yes. And so the next one would be like a 4 by 2.
Gotcha. And am I showing it like you're describing it?
Yes, ma'am.
Awesome. So you're probably thinking the next one here, and
Would be
yep, go ahead.
a 5 by 3, yes.
Beautiful. All right, so we have it increases by 12. We have this way of using numbers to organize our thinking and call it a 3 by 1, a 4 by 2, a 5 by 3. Let's see what other ideas are in the chat and keep them coming too. And Davenia, am I saying your name correctly? Can you confirm or correct me? I'd love to hear more about your top side is longer. Top side is longer than the bottom side. What do you mean by that?
So the one side of the L increases by 1, but it has like 3 on one side, and then the other side has just the 2. So it always increases by 1. So basically increases by 6 each time. Ooh. So one side's just longer than the other.
And which side you said the top side was longer, right?
I should have said the left side is longer than the bottom side.
And I think that's really similar to what our previous speaker was talking about. And I'm curious, why did you choose to group the red one on the left side?
I don't know. I actually just saw it as one long side. I didn't see the bottom as a long side. I just saw that as like kind of like a tree, like it just connected to it. But the one side was just, I don't know, from the red up. That's how I saw it. I didn't see it from the red to the side.
Yeah. And so, mathematically, when we start to look at these ones where we've decided that the red is in the vertical piece, it can make things easier or harder when thinking about the mathematical representation. Stacy, you bring up this idea of C and C plus 1. But one thing I'd love to bring up here is, did anyone see the red die as part of the bottom? If so, feel free to turn on your mic and tell us, your ideas here. Did anyone see it like that?
I just noticed it when Davenia talked about the red die, and I said if you rotate that red die so the dots are going horizontal, then you might see a column and a row that are the same length.
And why might that be useful?
I'm just thinking, like, if you were trying to come up with some type of an algebraic expression with it, you'd have 2 of the same thing. So maybe like if our figure number at the beginning is 1, we could say 2 groups of 2 times 1, and then 2 groups of 2 times 2, etc.
So now we're starting to think of decomposing the shape, moving things around so that we can write different algebraic expressions. Very cool. Samaya, am I saying your name correctly? Can you tell me about this triangle that you're noticing?
Yeah, hi. My name, you could, if possible, say it as Saumya.
Saumya, thank you.
The pig and the cat, yeah. So the triangle I thought of after you mentioned the point about the dots on the red dice. What if they were horizontal? So then it seems like it would be a right triangle with 3 dice as the height and 3 dice as the base. And that would make it isosceles. But I didn't see it as isosceles at all until you mentioned the dice changing the orientation.
That is so cool. So if we change the orientation, which I've kind of done in that new image,
Right.
Now you're looking at just counting the dots on the bottom and the dots on the side?
Right.
Oh, that one was cool. I haven't thought about that at all. All right, folks. This routine is all about having students look at these patterns and trying to verbalize what they see. Because so often when we ask kids to find the next one, which is usually where we go in this like pre-algebra concepts here, we'll say find the next one or find the 10th one. But that step before that they really need to work on is describing how they see it. Because one person will say it increases by 6 when someone else says it increases by 2. And how can it be both? Well, we just showed that here. So we're going to use this in our rich task coming up next. On slide 9, I have the rationale for why we do rich tasks. This is very near and dear to my heart and also grounded in research. The National Council of Teachers of Mathematics writes out in Principles to Action these 8 math teaching practices. And you're going to see today our goal is all about this pre-algebra, this looking for patterns. This task involves multiple conceptual understandings. You're going to have great questions to ask each other. We're going to support some productive struggle, and our discussion is all based on student thinking. Before we begin, I'm going to give everyone the opportunity to take the problem-solving oath that's on slide 10. As I read this out loud, if you would like to take the oath, go ahead and put your name in the chat box there. I, insert your name, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. And I can already see tons of names here, great problem solvers in the chat box. And our task is on slide 11. Typically, when I see growing patterns, I usually see the first, second, and third. Here, we did not show the first figure. Instead, we showed the second, the third, and the fourth. And it starts out by saying, how could you figure out what figure 1, 5, and 6 would look like? Did you break it apart into sections? Did you drag and drop? And you're going to showcase this using color. The slide here, these are a whole bunch of little boxes. And if you're not sure how to use the little fill bucket, there's directions on slide 12. But you can use these little boxes to show how you're seeing it. You can move things around to showcase how you're moving it. And if your group comes up with multiple ideas, yay! Just make duplicate slides and show as many ideas as you have. So here we go. I'm going to create breakout rooms. Please turn on your mic, say hi to your new buddies. And you can head down to your slide. Group 1 will be on 13, Group 2 will be on 14, and more. All right, breakout rooms are open. So if you're not as familiar with Zoom, you might need to minimize your browser. There's going to be a little message that says, you've been invited to room number, and it'll tell you where to head to. If you're watching a recording of this, I usually give participants just about a minute in their rooms before I go in so that they can have some time to introduce themselves without me being there. And then I'll look at the slides to see evidence of people who are starting up right away. And if they're not starting up right away, I usually head to that room first just to hear kind of what's going on.
stage 1 then,
Would be just this way, I feel.
yeah, but it doesn't fit the pattern. It looks like it does, 1 by 1. Yeah, okay.
2, 3, 4, 5.
Because isn't it whatever the stage is, it's like a 2 squared, 3 squared, 4 squared, and then it adds 1 less on the top and 1 more on the bottom. So yeah, so then this doesn't go there. Stage 1 doesn't have anything on top.
Why? It should have, no?
No, because if it's a 2 by 2, right? If it's a 2 by 2,
Okay, so if you're looking at
it has,
understood.
if it's a 2 by 2, it has, it adds 1 on top and then 1 extra.
No, but then I could look at it as, I'm just thinking, you're saying 2 by 2, you know what, I'll just share screen so that we can...
Okay. Well, you're in group 5, right?
Yes, yes. So if you're looking at this 2 by 2, am I...
The one on slide 14, if you want to copy from that, you can as well. I'm gonna go ahead and because I went for the first one. Start. So then, if we look at a pattern, would it be 1 by 2? Or 1 by... Because it goes 3 by 2, 4 by 2.
Right, because it's increasing every time, right? It's going, the array is getting larger by 1.
1 by...
Yeah, I would think. And then it would have the 1 piece at the top.
hold on.
Because then otherwise it wouldn't fit
The pattern.
the noticing that like it's that mainframe rectangle with the side, like the side pieces adding on.
I'm trying to figure that out.
So let's see. Should we build what the 1 by 2 should look like? Because then.
So this is 1 by 2, right? With the top hanging, because then this would be the I'm gonna change it to a darker orange. So that darker orange, I'll do blue.
Yeah, so that's the 1 by 2 with the 1 piece on the side, and are we going it off? Oh, so we're assuming that figure 1 wouldn't have the 1 square on the right hand side. That doesn't happen until figure 2.
Right.
Correct.
I don't know. It's not. I don't know. I'm having trouble because the other one made more sense, but I'm trying to figure out how that works in the pattern. Like if
It should be one more block up on top. So
One more,
on top of the orange.
like another orange one here.
okay. I wouldn't put it there. I would try to keep your bases level. So let's move these down for a moment.
I really think it's just 1 by 1.
There should be nothing on the right. It should just be a what, 3? So it should be a 2 by 1 there. So that should just be, yeah, just that. And then 1 on top of that.
Right. So it's like basically like that little L with just, that's what you had. The one. So
So it
but
should be
I
a
think
2
you're
by
saying-
1 with the added 1 on top.
mm-hmm.
So it should be
2
3
by
stacked.
1. Would
Yeah.
2 by 1 look like this? This?
Yeah, that's a 2 by 1, but
Right.
if you could move,
Right here.
there's too many people working on it at once. All right.
I don't know how to use all those scribbles.
No, that's perfect the way it is.
Hi, group. Tell me about this green block.
I was thinking that if I can move the green from the bottom, originally orange, but then change it to green, and then move it up, then I would see a rectangle. And then I can do the same thing for all of them. So I can move the 2 on the right, bottom right, on the third one, and then move it up so that I can move this 2 up there. Yeah.
So they go up there.
Yeah,
Oh my
so that
gosh,
I can-
rectangles are way easier to work with, aren't they?
Yeah. But I don't know how to get. I use a scribble line to draw that line, but then I always see that you use arrow.
Oh, arrows are above the scribble. It's like the second one down in the line tool.
Oh.
So that's like a line arrow, and then there's another one in the shapes category.
It doesn't work. Sorry.
Yeah, so you could use either, but I think the arrow that even the scribble that you have there with your explanation made a lot of sense, and I'd love to showcase that one to the group too, because gosh, our rectangle's easy to use. I mean, that just made the problem so much easier.
Yeah, I'm trying to see whether I can see it another way. See, I just realized that if I move the horizontal, the last kind of like sticky out.
Working. So basically it goes 1, 2, 6. I don't know. So that's not right.
Hi there, group. I see so many connections with what you have here with the dice that we looked at in our routine.
Yeah, we're looking at it in several ways, Teresa, on 2 different slides.
Mm-hmm.
There we go.
But in both of them, it appears that you have a chunk in the middle and a chunk that makes some, like an L shape. Is that right?
That almost needs to go.
Mm-hmm.
On 19, we don't have an L shape for figure 1.
Mm.
But on 20, we do have no, it changed.
It's just move slides. Somebody's got a blank one in 18 that they're going to work on.
And Lydia, you know what's really funny is you mentioned that 1 is not the L. So I've done this task with middle school students before, and that came up, and the one thing I love about it is they're like, yeah, it is, it's just a lowercase L. And it's always stuck with me as one of those like funny things that kids say that I would have never thought of on my own.
Oh, that's cool.
Bless their hearts.
Oh my gosh, aren't they the best? I love middle schoolers. They will take anything that you say is not the case and find a loophole.
Oh, they will. Yeah, their humor is quite something. It's like when you do patterns with people. Oh, but that would be true unless they only had one arm.
Yes.
It's like, okay, seriously?
Mm-hmm.
It really is the nature of middle school. Okay, who's the armadillo? Colette or Lydia?
I don't know.
What's the armadillo?
Okay, making the table on slide 19.
Oh, that's called that's me.
Oh, okay, you show up as armadillo on my screen.
Oh, okay. Where did the armadillo come from? But yeah, so I was just trying to predict what will my figure 5 and 6 look like. So.
Okay.
At least in terms of area.
Oh, an area. Okay, yeah. And Colette, did we figure out number 5? Because you were saying that maybe you'd made there.
I'm still working on it.
Okay.
I changed number 1. I think I've got the L shape on number 5. I'm still working on the blue part.
Okay.
You know what? I am going to get rid of that 1. Okay. And then I'm going to go with 0, 2, 6, 12. Yeah, I got it.
Okay, good. Lydia, I'm looking at your chart.
Hello, everyone, and welcome back to the main room. And kudos for stretching your mind to really look for lots of different ways to see this problem. In the next part, we're going to have a math discussion, and I usually hold my discussions based on the 5 practices that Smith and Stein line out. I have an example on slide 28. You probably heard me or saw me bounce into your rooms as I was listening to you, probing questions, copying slides, even though you weren't finished, because I loved that rough draft version that you were working on. And then I've selected and sequenced them. In this case, because I wanted a lot of variation, I actually selected all 5 groups, which I normally wouldn't do, but that's part of my goals here. And I've sequenced them in order of what I think are the most conceptually easy to recognize to the most complex. So let's go ahead and jump into what this looks like in a discussion. On slide 29, there are some little boxes at the bottom. Those are for you to use. And as a group is explaining their thinking, what I'd like for you to put in the box there is the mathematical expression for either the 5th figure or the nth figure. You can self-differentiate for what you teach, but don't simplify or reduce anything. Just give it to us as that group kind of mentions it. So group 2, can someone explain to me the green pieces here? What's happening and how does that help you to solve the 5th figure?
Anyone want to do that? So I was thinking that the bottom right, I changed it to green, and then I saw that if I move it up to the top, then I can see the rectangle, the 4x2 rectangle.
So for you, it was important that you saw a rectangle. Did I hear that right?
Yes.
So by simply moving those, and Rumi, since you did that one, feel free to change to green the other one. So you're going to be writing an expression for a rectangle here. Either tell us the expression for the 5th figure rectangle or for the nth figure rectangle. What would that expression look like?
That's funny that when we actually stopped, that's what we were trying to come up with. We were trying to come up with a formula for that.
And this is why sometimes it's easier to look at the 5th figure. So what would the length and the width be of the 5th figure? And so that could be an expression there, but then figuring out how it works for n is that extra step. I know it's not always required in a lot of the early elementary when they're figuring this out, but figuring out that 5th figure, what's the length and what's the width to make that beautiful rectangle? Because the cool thing about this group is they have figured out how to get rid of the L. They're like, we don't really like that L, so let's just get rid of these green pieces here. Let's move them up and make a beautiful little rectangle. And if you were the one in blue here, could you tell us, is the bottom part the x or the x plus 2? Can you just explain to us your expression, the one that's in blue?
So I saw it as the stage, which is the x, and then the vertical or the height of it is always the stage plus 2 more.
Awesome. So we've got our x down here, and then we have our x plus 2 is the vertical.
Yes.
Neat. And so that 5th figure, someone had 5 times 7 is 35, so they're able to figure that out. If you hadn't had a moment to yet, go ahead and write out your expression And then just keep with the same box, whichever box you're in here, just keep with the same one in the next couple. And we'll see if we can find several expressions that make this true. All right, and move at your own pace, but on slide 30, we have group 5. And what was neat about this, they did start going even further into a different direction, but I kind of snagged this image in their mid-thought because I love their rough draft thinking here. This is the 5th image. Am I right, group? Is this the 5th one?
Yes. Yeah.
And you found
Yeah.
something kind of cool in the shape of it. Did you want to describe this orange and yellow figure and what you noticed here?
So we noticed in all of the figures, it was the stage that it was at, squared in all of them. So you would have the stage and then you would square it. And then what you would also have is whatever the stage is, those leftover squares was double whatever the stage was.
Oh, okay. That's cool. That's different than I thought. So let's hear that again. What about the double? How did you get the double?
So whatever the stage is, you get that extra row at the bottom. So that's 5.
Can I change the color of that just to bring that out a little bit? So there's that 5 in pink.
And then you also have 5 more.
I'm only counting 4. Where's the 5th?
On top.
Oh. So kind of using Remi's idea of like, hey, let's just move that down.
Yeah, we never really moved it down. We just said we were more summative, more additive. It was more additive that, you know, you could move it over and stick it out and it'd be twice the length. The length would be twice.
Wicked cool.
Yeah.
And I saw here somebody in blue. Can you just tell us, in using the colors there, where did you see the n squared part at?
Oh, her stage box, when she said 5 by 5, I looked at that as n times n, or n squared.
Oh, nice. So that 5 by 5. And how about the 2n? Where is that at?
She said the ones left over were double the stage, so that would be 2 times the stage.
Gotcha.
2n.
Cool. So we've
You
got...
you make it really look ugly, you know, but once you simplify it, it'll come out to the same thing, because you could do n squared plus n plus n minus 1 plus, you know, but then in the end of the still will come out to the same thing. It just gets long. So instead of making it all so many broken up pieces, kind of make it a little bit more efficient in terms of looking at it.
Yeah, and you know, I like that you talked about those ends differently, because if we were to like look at the 2 different colors of the hot pink versus the like pale pink, we could even see where those 2 ends come from.
Yeah, the way you colored it in, yes.
Ooh, all right. Wicked cool. So you're telling me that this equation in blue is also the same as the equation on slide 29. They look totally different. We're going to keep going with that and seeing how the expression or the equation matches the visual, even though it doesn't look like it matches the algebra. So join me on slide 31. And if this group wants to tell us a little bit about what you saw here, what's going on in your representation?
Okay, we noticed the square. So we turned the square, sort of that turquoise blue, going from 2 squared down to 1 squared. We noticed there was always 1 extra on the top left column. So we left it orange. And then we noticed the bottom row would be, there were consecutive odd numbers, but as we look closer, we noticed it was 2 times the figure number minus 1. So we were in the process of making those bottom rows all turn yellow. Mm-hmm. And we eventually got to the squares were the turquoise, the 1 was the orange, and the bottom row was all yellow.
So the 2n minus 1 is really an interesting thing to look at. You made that yellow, and I see somebody else has it there also. But in our previous group, they didn't say 2n minus 1. They said 2n. How is 2n minus 1 down here on slide 31 the same as 2n on slide 30?
You have to then add that one back that's up at the top.
So this one here, this is like the sneaky guy, right? I kind of graded a, that's not a very good color. I'm gonna change that to green just so we can really see it. So here we've got this extra one. And so now we can get into mathematical properties. Like if I'm gonna tell a student that 2n minus 1 is way over there on the left side of the expression and the plus 1 is way over there on the right, that we can combine that to just be 2n. Like that's something that my algebra teacher told me, but I didn't really trust them. I was a very untrusting math person. And so I needed to see the visual. And here you've convinced me that we can do just that. Let's explore a couple more. On slide 32, this group saw it differently. And again, your task is when you hear what they did to write an expression that shows how they did it. Not a reduced expression, but exactly how they did it. So group 4, take it away.
Lydia, can you go ahead and start how you saw it?
Yeah, sorry, I was just trying to mute. And yeah, so if you hear my explanation, it's going to be a lot of mathematical thinking, even though it was a lot simpler. I complicated things, and the way I saw it was the L, the outside L, the horizontal was increasing in odd values. So 1, 3, 5, 7. And then the vertical was increasing just from starting from 2 and going 2, 3, 4, 5, 6. And then the rectangle in the middle was, there's nothing in the first one. But then after that, it's 1 by 2, 2 by 3, 3 by 4, 4 by 5, and it continues. So that's what I ended up seeing. But thank God for other perspectives, because there were so many easier ones in the end.
So you saw 3 sections: even numbers, consecutive even numbers, consecutive odd numbers, and a rectangle. I see people.
Consecutive numbers, not even, but just starting with 2, it goes 2, 3, 4, 5, 6. So the oranges, if you notice.
Oh, so I see. Those weren't even because they could be a 3. They're just consecutive.
Mm-hmm.
Thank you for clarifying that.
So I'm looking forward to seeing what people are putting, because our group, when we talked about this with Lydia, I was like, okay, there's 3 things happening. This is really complex. How do we put it all together? So.
And when you say 3 things happening, you're bringing in the algebra of what I should expect to see from my expression. A something plus a something plus a something.
Yeah.
And then, you know, as teachers and experienced algebra folks, we might want to combine some like terms. We might want to do some different properties. But as they did it, it's a something plus something plus something. And I love the one at the bottom that even used the little curly brackets. So I'll change that one to blue. If you can tell us which pieces align with what pieces up above.
This is Lisa, and I don't think it works. I was looking at figure 3, and I see n plus 1 as the orange vertical, and then n plus 2 as the horizontal sort of turquoise, and then n times n plus 1 is the blue rectangle. Oh, that should have been minus 1 though. Ooh, that should be a minus 1 instead of a plus 1 there, I think. Let me see if that does right. anyway, that's what I was looking at was that order.
Oh. All right, so we have our something plus something plus something. We knew that was pretty important to have to do. And we're saying that this expression is the same as the one on slide 31, and is the same as on slide 30, and is the same on slide 29.
+1. I don't think mine is right though, Teresa. When I look, because I was just looking at figure 3. 4, 1, 2, 3, 4, 5. So n+1 is orange again. n+2. It falls apart there on n+2 because that only worked with figure 3. So that's where I need to go back and change that to 2n-1 right there. Let me see if I can do that.
So what's really cool here is now we're like determining whether or not these expressions work for all. So it might work for 3 and above. And was it this group that was talking about the very first phase and how it doesn't have an L? Like that first phase was becoming a problem with some of them. And what I really like to bring out about that first phase being difficult or, not following a pattern or something is so often when we do these growing patterns, we'll stop at 1, or maybe we'll even make the knot. We'll do like the 0 phase. But do we ever do the -1 phase? Do we ever do the -2 phase? The -3? And are we comfortable with like, it's okay if we don't have an equation for the -2 phase. That's all right. So I don't have answers to those, but it is questions that I'm posing to myself all the time. We do have one other that looked at the negative space. So let's take a quick peek down at slide 33. And again, try to figure out what the 5th figure is or the nth figure. And group, tell us just how did you see it?
Hi, Teresa. So our group, very similar to I think the group that came that we just looked at. We were looking at the negative space, but not just that. The fact that there's that rectangle, like that core rectangle, like 2x1, 3x2, and then there is a constant as well, like that one green piece at the top that's always there. But then on the side, there are the pieces that are being added. So there are 3 different things going on. Similar to the previous group, like we noticed there were 3 different things that were happening in that pattern.
Neat. And I can clearly see kind of in your work that +1, you've used a lot of color and boxes here to just make it really clear to me. And so the question I would pose for students, even at homework time, is do all of these expressions actually equal the same thing? Like use the visual with it, use the expressions. There might be some errors in it. It might be exactly as intended. But on slide 34, I'm starting to put a collection of these ones that we had talked about. And the question is, are they all the same? Are they all equivalent? And what we can discover is through activities like this, those skeptical mathematicians like me start to understand what's on slide 35. Distributive property, order of operations, commutative property, combining like terms, and all these other things that we just kind of tell without showing. And so what I hope to show today is how we take a 3rd grade standard of which one comes next, and we bring it all the way up into Algebra 1 and everywhere in between. So folks, that is the top of the hour. Thanks for joining me. I'm going to stay on if anyone has any questions. I do have frequently asked questions on slide 36. And if you want to see other topics or grade levels, put them in on slide 37. I've listened to you all, and the next couple coming up, I'm going to do a primary grades, middle school, elementary grades, and a high school in that order for the next couple weeks. Of course, they're going to stretch to multiple grade levels. That's part of Rich Tasks. But hope to address some of the things that you're teaching. So if you have questions, stay on. Happy to chat. Happy Mather Days, and hope you have a wonderful rest of your Saturday.
Thank you.
Thank you.
Thank you. Teresa, I was gonna, when you were talking about what can you do to get like a -1 figure, -2, so I was thinking start with, take something that's decreasing, a decreasing pattern, not show that for kids. Of course, then they get to the point where, depending on what their pattern is, they run out of no figure 7 or 8, then it becomes something weird. But also, are you going to post the May lessons online? Or have you not been?
I did this morning. I have been crazy. You know, I would say I'm busy, but I had like several days where I just didn't want to do anything. I was a big couch potato. And so that was the real reason why, but they're up now.
Okay, because I was just thinking I should have signed up for last week, even though I couldn't come, so I could open it and see the slide deck. But that's good. Thank you.
Yeah.
You know, Teresa, I was trying to wrap my mind around how you would even show a negative growth pattern visually, because other than use the use of colors, because I think it would be hard. I think you would almost just have to use specific colors to then show. I don't know. Once you brought that up, I'm trying to wrap my mind around it.
I think we might be able to use ideas of decay to help us with this one, because at a certain point, either if it's linear, it's going to just stop. Like there's going to be nothing left. And so if I'm thinking of like a pile of cookies and everyone comes and takes some, I'm eventually going to have nothing. But if I'm looking at decay, it's going to get less and less and less and less and hit a limit, even though it doesn't actually go to 0. And so I'm going to play around with those, see if we can come up with a decreasing pattern, because those are real world situations. Like things don't always work for every number. And so we could even get into that like piecewise function idea. I don't know. I'm spurring with ideas now.
Well, that sounds very interesting. I'm curious to see what you come up with.
Challenge accepted. Let's see. Lydia, you said you're moving to elementary math. Resources to recommend. Do you have a grade level in elementary, like upper elementary or primary?
Lower. I'm doing grade 1, 2, and 3, and I'm used to teaching 6, 7, and 8.
Gotcha. Folks, we can crowdsource this one. I'll tell you some of my favorite resources. You know what? Let me think on that one and get some resources, because our next session is primary grades. And so I'll make sure that I have a little resources tab with like extra wonderful things to put in there. There's almost too many to spout off, but yes, let me make sure I do that for next week. And Lydia, thank you for your card. That was it made my day.
Oh, you got it. Yes. I'm so glad.
It made my day. Thank you.
Oh, you're more than welcome. We do that every year, and so I was like, I don't know how to ask her for her address. It's going to sound creepy.
I'm in a very similar position. I like to send people cards and stickers. So, folks, I have, let's see. So this is my mathy water bottle. Whoops, my Zoom camera's not letting me. I kind of put all these little like math stickers from different folks on it, and I even got some new ones. But oh, my Costello meth came off. Anyways, I have a bunch of problem-solving oath stickers. And if you want some, shoot me your snail mail address, and I will send you some problem-solving oath stickers. They're dishwasher safe, so like I throw this bottle in the dishwasher all the time, and you can stick them on your laptops too. But
well, thank you.
Lisa, yes, the Virtual Math Summit. Do you want to plug that for us?
I'm typing another one. Just go to that website and sign up for it. It's hosted on July 28th and 29th, I think, this year, or 29th and 30. All of the videos are going to be up for 10 days, and that part's free, and then you can stay up for 30 days for like $20. But I've gone to the last 3 years, and even though I teach middle school, I always pick up something new. I say, oh, now I know why they do this, or now I know why they don't do this, because we're missing out on some of our teaching. But it's wonderful. they're going to do a lot of, and I haven't looked at last week. She sent out a little podcast thing, and she was talking about the people who are going to be presenting on math fluency. So I'm really excited about those.
Absolutely. I was very excited to be a part of that. So definitely join that. It is free for 10 days. It's amazing. And Stacy, I use Camtasia for my recording. The university buys that for me, so I use it for my regular teaching also. I want to say it's one of the more pricey programs, but if you're curious about how I made that slide, what I really just did is I had an MP4, and you can go to like convert MP4s to GIFs, and that's what that is. It just turned it into a GIF, and it'll just repeat and go on a loop like that. All right, folks, any other questions?
Yeah, Teresa, I have some tech questions.
Yeah, go for it.
Where was it? Okay, when you were, when we first started with the dice one from Fawn, you very quickly and easily, like in that bottom right with the pink squares, you actually extended the squares really quickly and they matched perfectly to the grid. Now, is there a shortcut to that, or do you just do it really fast because you're used to it?
Absolutely, there's a shortcut. You're going to hold down the control button, or if you're on a Mac, it's the little squiggle.
I'm on a Mac.
Yeah, so hold down the little squiggle button and click multiple squares.
Okay, and it'll still create the border and fill at the same. Or no, it's just filling in the same color because the border's behind.
Yeah.
Okay.
So that's all I did with that. You can also do some fancy things with dragging them. So I'm on slide 8. There's a lot on this page, but I can do a drag select and change them all to orange. But that gets kind of tough when there's a lot on your page. So I usually just kind of click around the pieces that I need, holding down control. And do it that way.
Okay. And when you made these slides, Teresa, did you make a grid and then put on all these individual squares? I'm trying to figure out the technical part to make something like this.
And I can, it won't take that long. I can kind of walk you through the steps on slide 9.
If that's okay.
Yeah. One thing I found out if you're going to do something like this is make them transparent, because people like to drag and drop those squares. If they're white, which I've had this happen before, then they'll try and move one, and then order matters. Like, what order are they all in? So I just inserted a square. I'm going to make it transparent. I'm going to duplicate just a couple to get it started. And Google does a nice job with aligning it all. So now I have like a 2x2. I'm going to drag select. So pressing my mouse button down and dragging captures all 4, and Control D will duplicate that. So then I just kind of do that a couple times and I'll get my grid.
I'm glad she asked that. Now I know why everything was moving when I was selecting. I was thinking it was actually a table.
Yeah, so in this case, that's exactly what it was. I use different things. Sometimes I'll even use a background that's grid paper. But this time I wanted you to move it. That was the essential part, and I wanted you to do it in a collaborative space. So this task actually comes from CPM, which is an amazingly fabulous resource, and our CPM tiles, they have one of these that moves it around. The only downside to that is that it's much like when you go off to virtual manipulatives, only you can see it, or you can share your screen. And I really wanted to kind of explore what happens if we're all on the same screen at the same time. So just kind of continuing with this, I would select the ones that I wanted and then change them that color. And now all these are our boxes, a whole bunch of boxes.
Okay, because I often you have the background, you save it as a, you take that slide, save it as a background so that nobody can change it. You did it differently this time because you wanted us to be able to do that.
So I'm demonstrating that right now in case other people have that question. So I saved it as an image and moved it in as a background. So slide 10, you can't move around at all. It is just a background. Slide 9 is a whole bunch of little mini squares that are all transparent because I want you to move them.
Okay. Thank you. Thank you.
Mhm.
And then one final one. When you were telling us we had 1 minute left, did you go to each of the slides in each of the groups, or did you just apply? Is there a way to just apply that to everybody at the same
There
time?
is some apps, some extensions that you can download that will let you apply that to all of them. But since I work with school divisions that may or may not let you download extensions, I try not to model them. Alice Keeler has some fabulous codes to use, but yes, what I did here is I made the box, I put it where I wanted it, I put the color in that I want, and then I copied it and just pasted it on all the sides.
And just went to each of our group
Yep.
pages.
Yeah, I just control V'd it to each group slide. It only took me a couple of seconds because of the size. If I have several hundred people, that gets a bit tougher, but typically I don't.
Okay. That's awesome. Okay. Thanks,
Yeah.
Teresa.
Thank you,
Have,
Teresa. I have
have a
one
good week,
question.
everybody.
You too.
Thank you. You too. I have one question,
Yeah.
Teresa, which is that I've been watching some of the videos of the earlier sessions that are up on your YouTube channel, and I'm amazed at how well you've exploited the visual nature of this medium. So I was wondering if I have a Montessori background. So so Montessori is such a visual, concrete, way of introducing math to a child. So I was wondering whether you had that exposure anyway, along the way as a Montessori person.
I would imagine that was just part of where I should have gone to school growing up. But some of my background is I'm pretty artistic. I love art, and my favorite teacher, like the reason I became a teacher, is Miss Veer Heller from 6th grade, and she was the art and math teacher. And what she did is she showed me like that. She showed me a lot of this visual stuff that, if math is tricky, stop looking at it in terms of numbers and look at it as visuals. And so this idea that we did today of decomposing and moving things around is something that she taught me then. She really embraced the draw it out, like don't start with numbers, start with images. And then, that kind of went dormant because that wasn't valued in the next couple of grade levels. And then when I got into college, I was actually a computer science and math major and kind of didn't know where I was headed. Eventually moved into math for teaching. But I took a lot of the math classes for engineers because they focused on problematic situations as opposed to practice this formula. So that's just kind of my learning style, where that came from. I haven't had any specific Montessori training other than I feel like that's kind of in my nature.
Thank you. That's really lovely. Thanks for sharing.
Yeah, sure.
Thank you, Teresa. You have a great week.
You too.
Yeah. Bye, everybody. Have a good weekend also. Yeah. Bye.